Hey guys, this video is on dividing radical expressions. So what we're really talking about is fractions that have radicals. If you watch the video on combining radical expressions, these first few slides we've already done. I just kind of threw them in there again. Okay, so we've talked about fractions when we have a square root of a fraction or an nth root of a fraction. We could separate it into the nth root of the numerator over the nth root of the denominator. And we only have some conditions. The condition is that the denominator can't be equal to 0, because when it's equal to 0, it's undefined. And I didn't put it here, but they can't be non-real numbers. So that means you can't have a square root of -9. So we'll deal with that later in the chapter. There will be a video on complex numbers that we'll talk about those cases. All right, so you might want to write down this property. Again, I just said it, the nth root of a over b is equal to the nth root of a over the nth root of b. Okay, our first example, square root of 12 over 49. So we're going to separate it into two square roots, the square root of the numerator over the square root of the denominator. And then simplify each one. The numerator, that's 2 times 2 times 3, so a 2 will come out, a 3 will stay inside, and then the square root of 49 is 7. Okay, you might want to pause the video and do number 2 on your own. Okay, so we separate it into two radicals, the square root of the numerator over the square root of the denominator. And if you use method 1 for square root of 80, you would use 16 times 5. Or if you use method 2, there's 4 2's and a 5. So that means 2 2's will come out. So you end up with 4 square root 5 all over 11, because the square root of 121 is 11. Okay, same thing here. We just added some variables to the problem. So we're going to separate into the square root of the numerator divided by the square root of the denominator, and then simplify each of them. 75 is 3 times 5 times 5. Remember, your calculator has a factorization button that gives you the prime factorization. You just have to input the number like 75, then hit equals, and then hit shift, and then the fact button, F-A-C-T, and it'll give you the prime factorization. That's on a Casio FX991EX. I'm sure other calculators do it as well. Okay, so on the top we got 5y to the 5th square root of 3y, and on the bottom is 6x squared. Okay, let's do number 4. Separate. And then simplify each one. Square root of 27. 27 is 3 times 3 times 3, so there's a pair of 3's. A 3 will come out, a 3 will stay inside. And then the index is 2. Whenever it's not written, it's a 2. 2 goes into 14 7 times, so there's no x's that are left inside. And in the denominator, square root of 49 is 7, and 2 goes into 10 5 times. Okay, just cube roots here. So we're looking for groups of 3. If you use the prime factorization method, Or if you write it as a product of perfect, you write it as a product where one has to be a perfect cube, then you can do it that way also. Okay, separate, and then simplify. The denominator is easy. Cube root of 27, that's just going to be 3, because 3 times 3 times 3 is 27. The numerator, you could either use the prime factorization. There's 3 2's and a 5. Or you can rewrite it as the cube root of 8 times the cube root of 5. Either way, you should get 2 cube root of 5 all over 3. Alright, next one. Very similar, we just have variables this time. Separate and simplify. 16, there's 4 2's. So we're looking for groups of 3. So a 2 will come out, a 2 will stay inside. And then divide 3 into 6, 3 into 8, which is 2 times with 2 left over. In the denominator, cube root of 125 is 5, and 3 goes into 6 twice. It's always a good idea to put a little dot in between for multiplication, just to keep it separated. Otherwise, it might look like x to the 23rd power if you put it too close together. Okay, example 7. There's a couple different ways we could do this problem, but what we're going to do is we're going to go in reverse. We're going to write it as a single fraction, and then we're going to reduce the fraction. We could also simplify the square root of 24 first, but we'll go with this method right now. So does 3 go into 24? Yeah, it sure does, right? 8 times, so that gives us the square root of 8. Are we done? No, of course not, right? We've got to keep going. 8 is 2 times 2 times 2, so a 2 comes out and a 2 stays inside. We're going to do the same thing with example 8. Write it as a single fraction, and then reduce. 2 goes into 30 15 times, and there's 7 x's on top and 3 in the bottom, so that gives us 4 x's on top. Nothing left in the denominator. 15 is 3 times 5, so there's nothing we can do with that. But the index is 2. 2 goes into 4 twice, so we have an x squared outside and no x's left inside. Alright, so this will be a new topic. It's called rationalizing the denominator. So we have a rule that says that a rational expression, in other words a fraction, is not considered simplified if it contains a radical in the denominator. So we cannot leave a square root in the denominator. It's okay in the numerator, but not the denominator. There's some reasons for that. You know, calculators haven't been around forever, right? Before we had calculators, we had slide rules. And before that, you had to do it by hand. And there's actually a... off track. Sorry. No, I was just going to say that there's actually a method for simplifying square roots without a calculator. But nobody does it anymore because everybody's got a calculator. Okay, anyway, sorry, I got off track. Let's look at the following here. Square root 2 times square root 2 is square root 4, which is 2. Square root 7 times square root 7 is square root of 49, which is 7. And the same thing with square root 12. So you could see that whenever you multiply a square root by itself, the result is a radicand. So here's our procedure. If we have a over the square root of b, so you notice that the denominator has the square root, not the numerator, then we're going to multiply the bottom by the square root of b. And whatever you do the bottom, you got to do the top, right? That's what that first part says. The second part is if you have the square root of the fraction of a over b, then you're going to separate it and then multiply it by the square root of b over the square root of b. Okay. All right, here's our first problem. Square root of 2/5. So we're going to separate it first. Then we're going to multiply it by whatever the denominator is in a radical. So what's our denominator here? Square root 5. So we're going to multiply the bottom by square root 5 and the top by square root 5. Okay, on the top we can multiply that, right? What's the square root of 2 times the square root of 5? That's the square root of 10. And on the bottom, what's the square root of 5 times the square root of 5? That's the square root of 25. And then what's the square root of 25? Right, that's just 5. So square root of 10 over the square root of 25. And if you didn't want to write the square root of 25, you could just go ahead and put 5. And that's what our answer is, the square root of 10, because we can't simplify that anymore, over 5. All right, let's do number 10 now. Separate it. And then we're going to multiply both top and bottom by the square root of 8. In the numerator, square root of 3 times square root of 8 is square root of 24. The denominator is square root of 64. 8 times 8 is 64. And then simplify both numerator and denominator. The denominator will be 8. The numerator, there's 3 2's and a 3, so a pair of 2's we could circle. The 2 comes out, the 6 will stay inside. Oh, are we done? Heck no, right? We could reduce the 2 and the 8. So that gives us the square root of 6 over 4. 2 goes into 2 once. You don't have to write the 1, and 2 goes into 8 4 times. Now, we actually could have done that differently. We could have separated it and then simplified the square root of 8. So let's do that. Okay, the square root of 8 is 2 square root 2. So now, instead of multiplying the top and bottom by the square root of 8, we're only going to multiply it by the square root of 2. So now in the numerator, square root of 3 times square root of 2 is square root of 6. In the denominator, we have a 2 in front, and then square root of 2 times square root of 2 is square root of 4. And now we can simplify the square root of 4 to a 2, so it's 2 times 2 in the denominator, which gives us the same result. So there's 2 methods of doing that problem. There's actually a third. From the very beginning, instead of multiplying it by the square root of 8 over the square root of 8, we could have multiplied it by the square root of 2 over the square root of 2. That would make the denominator a square root of 16. Okay, I know people don't like it when we talk about all these different ways of doing the same problem. But hey, that's math, right? You gotta love it. Okay, let's move on. So this one, it doesn't have a radical in the numerator, but we still got that same problem of having a square root in the denominator. So we're going to multiply the top and bottom by square root of 3. Now, so what's 6 times the square root of 3? It's just 6 square root 3. right? We cannot multiply the 6 and 3 to get 18 because the 6 is not in a radical. In the denominator, square root 3 times square root 3 is square root of 9. And the square root of 9 is 3. Are we all done? Heck no, right? We could reduce. 3 goes into 6 twice. All right, number 12. This one has variables. We're still going to separate. Now, what are we going to multiply the top and bottom by? Yes, square root of y. In the numerator, square root of x times square root of y is square root of xy. And the denominator is the square root of y squared. What is the square root of y squared? That's just y. We're all done. Okay, now we're going to talk about cube roots. So notice these patterns. The cube root of 2 times the cube root of 4 is equal to the cube root of 8. And the cube root of 8 is 2, because 2 times 2 times 2 equals 8. The cube root of 9 times the cube root of 3 is equal to the cube root of 27. That's equal to 3, because 3 times 3 times 3 is 27. Now, cube root of 5 times another cube root of 5 is the cube root of 25, but that's not 5, right? It's just cube root of 25. The point I want you to see here is that it's different from the square roots. With the square roots, when you multiply it by itself, you get an integer. There's no square root that's left. But if you multiply it by itself here, it's no good. So you have to be able to multiply by a number that will make it a perfect cube root when we're rationalizing the denominator. Okay, so that's what this is here. When rationalizing the denominator of a cube root, multiply the denominator by another cube root, which will make it a perfect cube root. A number like 8, 27, 125. And whatever you multiply in the denominator, you have to multiply that in the numerator. The denominator should be a whole number. We're going to write the numerator in simplest radical form and then reduce the fraction if possible. Okay, so remember, we're trying to make the denominator a perfect cube root. So if the denominator is a 2, cube root of 2, we're going to multiply it by a cube root of 4, because we want it to be a cube root of 8. If the denominator is a cube root of 4, then we're going to multiply by a cube root of 2. All right, let's look at some examples. All right, here we go. The cube root of 2/3. Well, we're going to do the same thing. We're going to separate it. So now we have the cube root of 2 over the cube root of 3. We need to make a perfect cube root in the denominator. A perfect cube root is a number like 8, or 27, or 64, 125. So let's think about the cube root of 8. We can't make 3 into an 8, right? How about a 27? Yeah, we could do that. What would you multiply the cube root of 3 by to make it a cube root of 27? Right, the cube root of 9. Also think about that 3 is just one 3. When we have a cube root, we need to have 3 of the same factor. So we need 2 more 3s. 2 more 3s is a 9. So we're going to multiply the denominator by the cube root of 9. This will make a perfect cube root. Of course, whatever you do to the denominator, you need to do to the numerator. Okay, so what do we get on top? That's the cube root of 18. And on the bottom, the cube root of 27. Now 18 is only a 2 and 2 threes, so that will not simplify. But the cube root of 27 is 3. And we're done. Alright, so the next one, 6 over the cube root of 4. Well, they're already separated, so we need to figure out what we're going to multiply 4 by to make it a perfect cube root. Think about 4. The prime factorization of 4 is 2 times 2. So there's already 2 2's, but we need 3 2's. So if we have 2 2's and we need one more 2, that's what we need. So we're going to multiply it by cube root of 2. By doing so, we're making the cube root of 8. So that's the number that we're trying to make it into. We have the cube root of 4, but we're trying to make it into a perfect cube root, and cube root of 8 is that number. So top and bottom by cube root of 2. Now the top. What is 6 times the cube root of 2? That's just 6 cube root 2. The denominator will be cube root of 8. And then in the denominator, the cube root of 8 is 2. Are we all done? Heck no, right? We can reduce a 6 by 2. So that gives us the final answer of 3 cube root of 2. Okay, now we're going to talk about rationalizing binomial denominators that contain square roots. So we're going to rationalize the denominator when the denominator is a binomial. That means there's a plus or a minus in between two terms. And we talked about this in the previous video, that whenever you multiply conjugates, the result is an integer. Okay, so the conjugate a plus b and a minus b are conjugates of each other. So here's our first problem. 7 over the square root of 5 minus the square root of 2. So we need to get rid of the radicals in the denominator. There's 2 of them in this problem. So you're going to multiply by the conjugate. This will get the job done. What's the conjugate of square root 5 minus the square root of 2? It's exactly the same thing, but the opposite sign in the middle. So we're going to multiply it by the square root of 5 plus the square root of 2. Whatever you're the bottom, you got to do the top. So now in the numerator, you're going to distribute the 7, and in the denominator, you're going to FOIL. So you might want to pause the video and do that. You should know how to FOIL after doing the last video and homework. So the numerator is 7 square root 5 plus 7 square root 2. The denominator, square root 5 times square root 5 is square root of 25. Square root of 5 times square root of 2 is positive square root 10. And then the inner terms, negative square root 2 times square root 5 is negative square root 10. And then the last terms, negative square root 2 and positive square root 2 is negative square root 4. Notice what happens to the 2 middle terms? Right, the 2 middle terms will always cancel. The outside terms will always be perfect square roots. That's why we get an integer. So square root of 25 is 5. square root of 4 is 2. The two middle terms cancel. So we have 7 square root 5 plus 7 square root 2 all over 3. Okay, before we do some more examples, I want to show you a little shortcut. Okay, so let's look at this rational expression here. 12x plus 15y over 6. The proper way to simplify that is to factor out the GCF in the numerator. What is the GCF in the numerator? 3. So factor out a 3 in the numerator. So factor out a 3, put that in front of the parentheses, and then 3 goes into 12x 3 goes into 12x 4x times, and 3 goes into 15 5 times, so 5y. And it's all over 6. And now we can reduce the 3 and the 6. 3 and 6 reduced by 3. So 3 goes into 3 one time, and 3 goes into 6 twice. So in the numerator, the 1 we could ignore because 1 times anything is anything. So we have 4x plus 5y all over 2. Okay, so here's a shortcut. Don't tell anyone. What we're going to do is we're going to find the greatest common factor, the GCF, for all terms. So look at the 6, the 12, and the 15. What number goes into all three numbers? And the answer is 3. So what we're going to do is we're not going to factor. We're just going to divide all of them, and this has to be done with all of them. We're going to divide all of them by 3. So 3 goes into 12. That would be 4 times. 3 goes into 15 5 times. And 3 goes into 6 twice. So now we have the same answer. So it's not really proper, but it's true. It works. Okay, so that's going to help out in some examples as we move on. But remember, it has to go into all three numbers. If it only goes into one number on the bottom and one number on the top, then you cannot do anything. Let's try a couple more. This one has a radical, not an x and a y. So in the top example, what number goes into the 12, 24, and 18? Right, 6. So you're going to divide all of them by 6. Six goes into 24 4 times. 6 goes into 18 3 times. 6 goes into 12 twice. So our answer is 4 minus 3 square root 3 all over 2. Now the denominator, now the bottom example. What number goes into all three numbers? There isn't anything, right? 15, 7, and 15. Nothing goes into 15, 7, and 15. It has to go into all of them. You can't use a 10 because the 10's in the radical, so it's got to be the numbers in front, the integers. So there's no GCF, so that's it. There's nothing to do. If you were to reduce the 15s, the 15 on top and the 10 on the bottom, then that would just be plain wrong, and you would get the answer wrong. You don't want that, do you? Heck no. Okay, here we go. So we have a radical in the denominator, and it's a binomial. There's two terms. So we're going to multiply by the conjugate. So the conjugate is exactly the same, but the opposite sign in the middle. And then we'll simplify. So we're going to multiply the top by 5 square root 2 minus 4, and the bottom by 5 square root 2 minus 4. Remember, it must be the opposite sign. Now on top, distribute the 6. On the bottom, FOIL. You might want to pause the video and work it out. Okay, so the top is 30 square root 2 minus 24. The denominator, 25 square root 4 minus 20 square root 2 plus 20 square root 2 minus 16. The two middle terms will always cross out. The outer terms are always perfect squares. You can see that they are 16. There's nothing to do with that one. It's already an integer. The square root of 4 is 2, so that's going to be 25 times 2. And then 25 times 2 is 50. 50 minus 16 is 34. Are we all done? You probably should say, heck no, right? There's a number that goes into 30, 24, and 34. 2, yeah. So divide all of them by 2. 2 goes into 30 15 times. 2 goes into 24 twice. Sorry, did I say that wrong? 2 goes into 24 12 times. And 2 goes into 34 17 times. And we're sure that was the biggest number because if we look at our answer now, 15, 12, and 17. Nothing goes into 15, 12, and 17. So we're done. With this problem, we still got 2 more. Almost done. Okay, same kind of idea. We're going to multiply by the conjugate of the denominator. Let's do that. So the conjugate is 5 square root 3 plus 4 square root 2. Exactly the same, but the opposite sign. Whatever you do the bottom, you got to do the top. Distribute the 3 square root 6 and FOIL in the denominator. Okay, so you should get 15 square root 18 plus 12 square root 12. The denominator is 25 square root 9 plus 20 square root 6 minus 20 square root 6 minus 16 square root 4. Now we got a whole lot of simplifying to do, right? The numerator, the 18, that's 2 times 3 times 3, so a 3 is going to come out, 2 will stay inside. The 12 is a 2 times 2 times 3, so a 2 will come out, a 3 will stay inside. In the denominator, the middle terms will cancel. In the outer terms, perfect square roots, right? Square root of 9 is 3. Square root of 4 is 2. Middle terms cancel. Okay, so now we have 15 times 3 square root 2. That's going to be a 45 square root 2. And then 12 times 2 square root 3. That's going to be 24 square root 3. In the denominator, we have 25 times 3. That's 75. And 16 times 2, 32. And 75 minus 32 is 43. Nothing will go into 45, 24, and 43. 43 is a prime number. So that's it. Okay, last example. This one has variables. Same process, right? Conjugate. Whenever there's a radical in the denominator, we multiply by the conjugate. It's exactly the same, but the opposite sign in the middle. Okay, so this time we're going to FOIL in the numerator and FOIL in the denominator. So when you FOIL in the numerator, square root of x squared plus 2 square root of x plus 3 square root x plus 6. The denominator is square root of x squared plus 2 square root of x minus 2 square root of x minus 4. The numerator, we could combine like terms, the two terms in the middle, because the radicands are identical. The square root of x squared is just x. In the denominator, the two middle terms will cancel. And then we're all done. I'll see you here for the next video. Have a good one.